Well, howdy everyone, and welcome to another electrifying episode of the High Voltage Live Show. I'm your host, Willie Snyder from NEC Code, coming to you live from the Mile High City in Denver, Colorado. I'm joined by my awesome co-host, Mr. King James Stallcup, over there at Stallcup Electrical Education, and he has put together a really awesome course for you guys that are getting ready to study. Want to pass your either your master's or your journeyman exam, and I'm really excited. All we ask is that you subscribe to the channel and 5 of your family members. Yeah, there you go. We're trying to get 1,000 subs in 12 weeks, or at least by summer. I think we could do it. I think your goal is pretty legit, James, and like I say, we're here to show you guys that James has the best online training period in the industry, and we think you guys will enjoy it. We really appreciate you guys joining us every week. It means a lot. I had so much participation with the NEC Code Myth of the Week this week. I really appreciate it. Over in the electrical code discussion for awesome electricians, we had so many people participate. That's really awesome. That group's growing. It's almost 17,000 now. So we just keep growing. All our different stuff keeps building, and we're trying to bring you guys the best content possible, and just kind of keep moving our show forward. I actually had a request from somebody that I thought was a pretty good one to do a segment where you just answer like 3 questions from the Facebook groups, just random questions, and you just answer 3 of them. You know, like, I think that'd be pretty fun.
Oh, that's fine. It's no different than doing podcast here. I mean, heck, one night I think I answered like 10 or 12. Just asking questions left and right. Mm-hmm. But yeah, it doesn't bother me. If they want me to do that. I know there's a lot of questions that get posted on Facebook, but I'm not on there all the time. I'm doing other things, and I just don't go in there and spend all my time on Facebook. I've got my Longhorn side I gotta go to. Some other things, Cowboys.
Gotta give you the hook 'em horns.
Hook 'em horns, baby.
But it just means a lot that everyone jumps in, participates, and we know everyone's busy at work and everything like that. So you don't have to watch these live. You can watch these at any time. We try to, I think we'll do the topic probably around, it'll be about 7:30 Central, 6:30 Mountain is about when we get to the topic. So you could always just fast forward to the topic and just, study, use that as like your study guide for getting that journeyman or master's exam. So really appreciate you putting that together, James. And I didn't get a chance. So actually this week, on the Myth of the Week, I actually asked the AHJ of the city I'm working in, and I was asking him about it, and he said it was a good question, and I didn't get back with him on it. But I am interested. I will let everyone know what he says on his end. I just think that myth was pretty interesting, but before we get there, I guess we're going to have to do the meme, right?
Yeah, if you don't mind. Everybody always likes me to give an update, so.
Do.
I'm gonna do a little screen share here so everybody can see we're moving along. I told everybody come 2024, you're gonna start seeing stuff starting to happen, and that's exactly what's taking place. So, what we've been able to accomplish here, this is going to be the new website, which there's already been a lot of people have already been over to this, but we've created here where here on the right hand side you've got your recent posts that were done, any comments. I've built all this in together so it just keeps a full tracking of what's going on. We got a link to all the different Facebook groups here, so if I wanted to click here, you can come over and see. Here's all the Facebook groups. You can go and check them out to know which ones we're basically the admins of. Another thing that'll be happening before too long, once I bring up the learning management system, you're going to see the new NEC deathmatch.
Yeah.
I've also got a link to the Facebook group and all of that. So we'll have that. There's a link to, I don't know why that didn't pull up. I'll have to check that link. Okay. We also have a link to the merchandise space here and other gifts of interest, which I'll eventually add more to that. But right now it's the publications. So you can
Dude,
go
I
in
think
there.
even Willie Jackerson even popped in a comment in there. I think might have
You
seen
might
him
have.
rolling in.
I
Yeah, might
think
have
you
seen
did,
him
matter of
rolling in.
fact.
I think
Uh,
he might
this is going
rolling
to be
in
the
there.
new state electrical license page. You can
Oh
come on
yeah.
here and check everything out. Uh, we're, we've got about half of it, the state's done so far. And there will be more things that we'll be adding into that. Say you want
Yeah,
to go in,
you were just showing me that Colorado logo. That was
yeah,
pretty
here
dope.
it is. Here will be the
Oh
Colorado
yeah.
page. And I'll, every
Okay.
one of these will have their own cool looking designs and everything. Of course, I did put the line there. I do that to upset a few of the people for King James. I did that on purpose. So, hey, sometimes you just got to laugh when you're doing this stuff. And
Yeah.
then you come down, it talks about what the requirements are. We got a nice little ride up here that's specifically the Colorado, just talking about it. And then if the course is based on the electrical code changes here. So uh, if you want to purchase the publication, we got a link down here. You can go and do that. Uh,
Nice.
the one I like, it is my site, so I'll put what I want on it. Might upset some A&M Tech fans and stuff, but yes, there is a Longhorn on there. It's my side. I like the Longhorn, so I like to have a little fun with my side. Anybody can appreciate that. I mean, you don't have to purchase a course. I mean, I actually
That's
have
funny.
fun when I'm doing this stuff. It gets to be a lot of fun just creating things.
Right.
And sometimes I'll make something, I'll start laughing, going, "Yeah, that's funny." There's no way that's coming off.
Oh,
So,
look who popped in. Looks like David Englehart's in the house.
oh,
Thanks for
cool.
joining. Yeah, it could be. I could be Willie Jackerson.
Now,
Possibility.
when you come in here, these are all the updated 2023 publications. You can go and get those. So if I wanted to look at the generator, transform, motor, compressor, as you can see, I've created all of them with their own cool little wallpaper and everything. Here's some other books of interest you can look at, and then here's a write-up, tells you all about it. And then you can go over here and you can purchase everything. And then
Nice.
you'll notice here the online courses, nothing's there, coming soon, but you'll see each individual course will look just like those publications, but with a little more detail because there's a lot of interactivity and all kinds of stuff that's coming in. Here's about page about us. I've got a write up here, talks about the educator's dad and I and everything. And then we also got a link here to the YouTube channel. And we tell you can watch it on all your devices, everything we're doing. If you want to
Nice.
contact us, I've got the contact page. And then the other thing, I'm pretty happy, you can actually go to blog or you can go to articles and it'll take you there. Uh, so if I come over here and I look at this, you'll see right here, this is electrical safety blog. And then we got a subscription where you can subscribe to the High Voltage Live YouTube channel. And then these here are articles that are written. So if you wanted to look at something I did say here on motor breaker sizing, you come over here. These are the type of articles we're putting out, by the way. So
Nice.
it come from the Journeyman exam prep. So if you want to learn more about the publication or you want to look at purchasing, you can. And up here, you can go in and size whatever you want. So if I was going to do 2 or more motors, it'll click you down here and you'll see right here, we've got step by step how to do all the calculations. And this will be in the Journeyman presentation as we do
Nice.
this. And then check this out. Right here, you've got all the fill in the blanks, just like we're doing for the Journeyman prep. And then right
Nice.
here, I've got the answers here. So
Okay.
you can come in, follow this, and there's 3 calculations in this one. So we do the maximum size here. There's the answer key. Then you scroll up. then we got the minimum and maximum here, and here's the answer to it.
Nice.
So what I tell people is when you come in and you look at these articles, we've really, really put a lot of time and effort into these articles.
Yeah, and just so everyone knows, I actually took James's continuing education for 2020, and I'd say that's probably the best I've ever taken out of all the different ones. And you know, it was at a time when we weren't allowed to really do any in person, so you know, it was like during the whole lockdown COVID thing, so I wasn't really able to take any classes at any of the other schools out there. So really appreciate that.
When the new ones that's coming out, it's better. I mean, what we had before was fantastic, but I've gone upgrades on everything.
Oh yeah.
I mean, just looking at the website and the graphics, everything we're doing, we're putting a lot of time and effort. This is going to be a one-shot deal, and from that point, it's easy to upgrade at that point. Now, one of the things that we're also going to be doing is when I get to the design, will be the last one, or not the very last, but we're going to put on the Journeyman, the calculation courses. We're going to put on the 2023 illustrated changes, the 2020 illustrated changes, and then we're putting the generator, transform, motor, compressor on. After that, we're going to do the design book. The design book's about 1,300 illustrations. So
wow,
it's going to take time. The one I'm working on right now we're doing is chapter 16, which is grounding, because grounding by itself is around 180 slides, somewhere to 150, 200. I didn't count them, but
right.
I will tell you, it's very detailed, and all the colored wires and everything for the grounding and everything, it's all going to be there. And I'm telling you, you might have seen some other illustrations. I'm telling you, they're nowhere close to what these illustrations look like. And that's what we're getting everything. When we do this, you know, we're spending a lot of money. But I will say this, when it's done, it will be the best online training out there. And then I'm going to have the publications done in color that you can purchase as a PDF, but they will not be in print because it costs you too much money to print it. But I will have them for sale in a PDF, or PDF, whatever they call it. So that's all I wanted to share tonight.
you look at like some of the other competitions that are online. You know, like the other competitors, they're spending a lot of money for audio crews, and they're spending money for video crews and stuff. And that's what I like about you, James, is you just do it all yourself, save all that money. Then, you know, at least you can get these people some good education. So I really appreciate that. It's awesome.
I'll say this, I want it done a certain way. And it, you know, people ask me, I have spent the last 10 years, it's one thing I study code still, but I'm studying all this other stuff. And just like I was showing the website, it's done in WordPress. It is a whole different other animal that you get into when you do that. And then I had to learn how to build out a learning management system. And then I had to learn to build online courses and all these functions and doing this and doing that. And everything has to interact together. So, you know, when I build an online course, I go through 6 programs to get to the final touch. But what I tell people, if I showed you how to do it, you go, that's easy. But what they don't understand is I had to go through about 50 programs and figure out which ones matched up together so it would do what I wanted it to do. So
awesome. Oscar's up in here.
Hey,
welcome in, Oscar. Appreciate you joining tonight, sir.
Right, you ready for the meme?
Yeah, let's do it.
That's enough gallivanting around tonight.
Yeah, I thought you'd like that one. That That was one I just kind of threw together for you. So
I got a question for you. Where are you drawing the energy from? The outlet or the receptacle?
From the receptacle.
That's why I always have an argument about them saying there's an outlet. Where do you draw the energy from? You don't draw it from an outlet. You draw it from something that's there. You got to draw it from somewhere.
Just like
an outlet.
just like me saying that nobody's been killed by an outlet.
That's right.
They get killed by the equipment, or they get killed by the receptacle.
That's hilarious. Okay,
yeah,
ready for
that's
this?
Funny.
We got a lot to do tonight. All right, let's roll it.
It's time for Myth of the Week.
Awesome. So I really love this Myth of the Week this week. We were doing a hotel a few years back, and one of the inspectors was like, "Oh yeah, you got too many cables in here," and I'm like, "What?" He goes, "Yeah, you can only have 3," and I'm like, "What?" I was like, "Where does it say that?" And so I kind of went back and forth with the inspector, and he, "Oh well, I'll let you get by with it this time, but don't try not to do it or whatever." And I'm just like, man, I was like, I really don't see an issue with this. And then looks like we got another Oscar in the house. Awesome, 2 Oscars showed up. Awesome, guys. Yeah, so I thought it was kind of bizarre. I'm like, what would be the reason for them saying this? And so I asked the AHJ, I asked the city inspector, and he was like, you know what? He goes, that's a good question. He goes, I'll bring it up at our meeting on Tuesday. So I hadn't heard back from him. He hasn't been back for an inspection, but I will get an actual answer from my city inspector to see what he says about it, because I was just interested, and I was like, I don't see why it's such a big deal, because I feel that what they're doing is they're taking the language of 334.80 that applies to NM cable and then trying to apply that same to MC. There is a 330.80B, I believe, that does indicate something about MC cables going through stud holes. But like I say, this one's really interesting. I don't see a issue with this. I don't see why you couldn't just pack that thing as much as you could fill in there. I think you might be limited by the 20 current carrying conductors from 310/15, but just a real interesting one, and I wanted to bring it your way, James. We've been doing a lot of bundling. We'll probably just keep doing bundling until we get through all of them, but I figured this would be a good one for you to slam dunk on.
Okay. Yeah, I'm used to getting a lot of these. It's funny because being an instructor all these years, I've already had this question asked before, and when you had told me about it, we were talking the other day, and I said, "Oh yeah," I started telling you everything. I said, "Yeah, I've already heard that one," And you were right. When you get over and you look at 334.80. That's where somebody gets in and they start talking about the type NM and NMC cable, and they try to apply that, and that's where you're getting down into the second paragraph where they talk about that. And what it says there, when you have more than 2 NM cables containing 2 or more current carrying conductors installed, and this is going to be a key word that we're going to talk about here in a minute as we get into others. But it says, without maintaining spacing between the cables through the same opening in wood framing, that is to be sealed with thermal insulation caulk or sealing foam. Okay.
Yep.
Now, that is where you're going to look at this. Okay. And they try to take this. Now, I want to bring up an analogy that's sort of the same thing. When I was instructor for NFPA and we first started teaching 70E, we had to pull back on a couple or most of the instructors. I think there was three of us that were allowed to teach it because they were doing sort of the same principle that they're talking about here. And what happened was when they would take and you would take and apply one of the hazard risk categories that was in table 310.15 CA, and you started looking at that, they would say, well, just pick out a similar task and similar type piece of equipment, then you can apply that group. No, you couldn't do that because there were parameters that were underneath, because I was on the task group and we did that, and there were certain parameters you had to meet. You just couldn't say something that's similar and then go apply that. That's sort of the same thing you're getting here. If they meant this exact same terminology as here, then it would have been over in 320 and 330. Okay. And it's not. So I just wanted to bring this portion up because I knew this is where it might come from here. And then you got the third paragraph, you get the same thing. And then you're going to see it talks about looking at table 310.15.
Yeah, and one thing I wanted to mention too is that in that 334.80 where it says more than 2 NM cables that are installed where thermal insulation is sealed, and that's a big thing there because a lot of times the residential HJ, and this is what I went over with the HJ, and actually he's not the HJ, he's just the representative for the HJ, but I went over with him like, hey, you know, I think they're trying to apply this to MC cable as being similar type cable, and then, you know, with the sealing, the insulation, the reason you do that in residential is because they don't know which one of those exterior walls are going to get sealed. Most of the time in residential now, with all their energy codes and everything, they're going to basically seal thermal insulation on all those exterior walls, so they don't want to sit there and pick and choose like some of the other guys do and say which walls need sealed, which walls you could do 2, which walls you could do 3, and which walls you could do 4, whatever. They just rather you just do 2 on all of them, and they don't have to sit there and spend a lot of time picking through them. So that's why they do it in residential that I've seen.
And then if you look at 320.17 and 330.17, it talks about where you're just based on the picture you had there's why I did this, where you're installed through or parallel to framing members. It refers you to which sections. 300.4 A, C, and D. Okay. C, we're not going to take a look at. So, and I brought this up the other day when you asked me, I said, when you're going through that hole, that doesn't have anything to do with it, because all you need to do is be what? 1.25 inches away. And as long as you're maintaining that, you can run as many through there as you want to. Okay. And that was one of the things I brought up right away when Bill and I were talking about it. Now, when you go over and you look at D, and it talks about cables and raceways parallel to framing members or furring strips. Okay. This is where they're talking about both exposed or concealed locations. And if you look here, if you're at the nearest outside portion of the service, how far you need to be away? 1.25 inches.
Yes, sir.
Same thing. Now, this is where I find everything. Now, since that's the case, I'm thinking, all right, now the only other thing that could apply here is if I had the cables and they were what? Bundled. Because as far as I know, the only thing I'm recognizing here is I need to be 1.25 inches away from the edge of the stud. That's it. All right. Now, when I come in and I look at my adjustment factors, you're going to look at 310.15 CD, and it's going to talk about adjustment factors. And it says it shall not apply to AC cable or type MC cable under any of the following conditions. And 4 is the one you're going to look at. And it says not more than 20 current carrying conductors are installed without maintaining spacing, are stacked, or are supported on bundle rings. Now, if you ran 3, 4, say you ran 5 in there, and you had 5 current carrying conductors in there. Let's say the neutrals were, that's only 10.
Right.
So where's my problem here? I don't see anything that hurts me on bundling, but let's look at exception number 4. If cables meeting the requirements up above, when more than 20 current carrying conductors are stalled longer than 24 inches without maintaining spacing, are stacked or supported on rings, a 60% adjustment factor shall be applied. Now this is where you've got to look and you're not maintaining spacing. And that's where they can hit you on it. Okay?
Right.
And therefore, I would say, now if I'm just going through the hole and then I shoot off and I'm not over 24 inches and I'm going feeding a plug, maybe one going down here and I got 2 running up, whatever, however I'm running them, I don't see a problem with 5 going through the same hole as long as you got that 1.25 inches. But now, if I come in and I look at that and I've got them going across, say 5 studs, 4 studs, 3 studs, I've got 24 inches, and I consider at that point it's bundling because you're not maintaining your spacing.
Yeah, that was funny, David. That cracked me up. Speaking of hockey sticks, shout out to my nephew Moose. He's playing an international hockey tournament for Arvada. So go Arvada. They're gonna be playing all weekend. I'll be streaming it. All his games on my Facebook.
That's cool.
Thing. So my news feed. So check it out. Go Moose. They his first game today they tied 1-1. So it's a lot of fun. If you guys like hockey, they're 14 and they're pretty intense. It was fast and furious today. So if you guys like hockey, check it out. So sorry to interrupt.
But anyway, so what I would look at, it depend on how it was installed, but it has nothing to do with the hole and how many are going through it. It has to do with the bundle and if you maintain the spacing from the edge. And that's the only things in the code that I'm aware of as it applies to this rule right here. So the answer is actually true and false. It just depends on the type of installation. But looking at your illustration, I would say you're going to have to do something with that because you're bundling at that point because you didn't maintain spacing because you were over 24 inches. Right. So then it would become a problem running 3 of those cables in there, AC cables or MC cables. And that's the way I would look at this particular myth this week. So now I am curious, is those some of the comments that we got in the when the myth was posted, or everybody saying?
Yeah. There you always get that 24-inch thing in there with the bundling. Mm-hmm. And to me, the thing I always thought was bizarre about this one is that maintaining spacing is not really defined. So is that one conductor width, like can you go through the stud really tight, then spread them out, then go through the stud really tight again? Because you're basically maintaining spacing,
Yeah.
So that's the thing, And that's a good one too, David. Yeah, we touch on that 10% of the run too. So what David's referring to, so if I was to go and bunch a whole bunch of conductors for 10 feet and then spread them all out for 100 feet, then they would only be bundled for 10% of the run, and that would be code compliant. So that's a good one, David. I like that one.
Yeah, we actually covered that. Was it last week or week before? We went over that. Yeah.
Yes, sir.
Awesome,
yeah, so it's really awesome having you guys all join up. But with no further ado, we got what Oscar's here for. Oscar's getting prepped up. He's gonna take his exam, so he wants to pass. He's been having a hard time with some of the other educators out there. It's been a little bit of a language barrier. It's really hard for him to understand. So I told him, well, come watch the video. James will explain it.
Well, Oscar, to help get you started a little bit, let me pop this up so you can sort of see this real quick. Let me go share screen here real quick. I was just showing this earlier, and I think this will be something that can help you to get you understanding how we do things. If you'll go over to the Stallcup, go to stallcupeducation.com and go over to the blog page up here. Like I just did an article here. And as you come down, you can start to see, we'll ask you an example problem here, and it goes step by step with the sections, and it shows you how to lay this out. We put it in the easiest format possible. And just like we're going to do tonight, going over what we did last week for the AC and DC formulas and Ohm's law and pi formulas, we have to fill in the blanks here. Well, this illustration has it, and then right below it, you see the answer key. So you can follow these sections up above and then fill in the blanks and see if you're doing it right. Okay, so just a little something that'll help you understand, you know, as you start getting into this, because like that's over current protection devices. We're probably still another 3-4 weeks away before we get to that. Okay.
And if it's not the best, Oscar, I want to hear about it, and we'll make sure we
it's
fix
the best.
it.
I ain't worrying about it. I've seen all the competition out there, and I haven't seen any illustrations like that. And
I agree.
They're very detailed. There's a lot of time, effort spent on it, and I think they look fantastic. But
Yeah,
okay,
I agree.
Let's cue up topic of the week. Looking forward to doing this. All right. Now, before we get kicked off on this, one of the things I want to point out is next week we'll start on doing wiring methods, designing our different types of wiring methods. We'll get into doing round and optical boxes. Then we'll get into device boxes, square boxes, and other boxes. That's probably as far as I'm going to get up to that point. Because it'll take some time, because we'll be doing same size and different size conductors. And I'm also going to talk about when you got the new rules for the equipment grounding conductor, and I'll get into all that and show you how to take them at 0.25 once you're over 4, and we'll go through all that.
Yeah, one thing I want to say I really liked about you know, I've been doing this 28 years, and I always learn every time you do these, but the one thing I really liked about how you set this up is just the confidence that when you do it, you know you have the right answer. You don't even second guess it. So I really appreciate about that, about your stuff.
Well, you know, one of the interesting things is Dad and I bounce off each other constantly. And when we were designing these calculations and everything, if you go look at the older versions and where we're at right now, we've even broken it down where we've simplified it more. And
nice.
Just like the one I was just showing you, I was sharing the screen and I was showing you the motor calculations. Right at the very first of that calculation, we had section 240.4G. Well, what that deals with is specific conductor applications. And it's something I'm going to teach when we get over there, and I'm going to explain. If I take anything at 125% or less when I'm sizing the overcurrent device, you go up to the next standard size. Anything above that percentage, you're going to drop down. And I'm going to prove all that as I go through it. The only place that doesn't hold true is when I'm doing phase conversion, because you have to protect the conductor. So therefore, you'll have to go over what that size is, even though it's a higher percentage. And then the other is transformers, where you look at 450.3, table 453A and B, but it has a note 1 and it says shall be permitted, so you can go up or down. And they made that change like 3 cycles ago. We used to go down, but now they give you the option to go up. And I'll explain all that when we get over there. But that's one of the things as we go through this it's going to all the little tips that I'm going to get is going to give you even more confidence. Just like last week when we were doing the Ohm's law and pi formulas, and I was telling you how to remember how to do those, and based on the will, you know, I actually had 3 guys that actually messaged me and said, you know, I didn't even think learning basic calculations like that I'd learn anything. They said I actually picked things up on easier ways to remember by a couple of the things you said. So, hopefully.
Well, and one of the things for like Oscar out there is like you learn to dissect the question. So, like if they're talking about something about the overcurrent protection device, you're going to go to Article 240. Now, if they're mentioning this and that, whatever, then you're going to be in 240.4D. And then if all of a sudden you get in these special conditions or special conductors or whatever, then you have to keep reading past 240.4D and go to 240.4G. And so then that would give you allowances to be a smaller conductor than what's permitted in 240.4D. So that's things that could trip you up on a test, and a lot of things they like to know, that they like for you to know. So,
sure.
As James knows, we get those in the nameplate posts all the time. So it's fun.
That ain't no lie. Okay, all right. Now, last week what we got into, we were doing the AC/DC formulas, and what I was giving everybody homework, we had these illustrations that were in the video, and I said just get you a piece of paper and go in and fill this information out. Now, to help it make it easier so you can start to learn this better, we have the known values, which is in the illustration. We've got 5 horsepower, 230 volts. It has an efficiency of 80% and a power factor of 90%. And this one happens to be a single phase. Now, if this was a 3-phase, as you remember, we did one as 3-phase last week in the that example problem. We added 1.72. One of the things is take the horsepower, and every horsepower you take each horsepower at 746 watts. So you get that value. And then everything else you multiply together and then divide it into that horsepower. And that's going to give you your amperage. So I have 230 volts, 80% efficiency, and a 90% power factor. Add all that up, multiply it together, divide it in your horsepower, and that's going to give you a current value of 22.5 amps. It's pretty simple. And
that's a good one to look at too. Because in certain cases, 22.5, you could use a number 12 gauge on a 25 amp or a 30 amp overcurrent device. And some cases, you know, depending on the appliance with the calculation, that's going to drive you to do something different, go to like a number 10. So you have to pay attention to what you're doing depending on the rules of 240.4D and 240.4G.
Sure. And for those watching, if you took the 5 horsepower times 746 watts, that's going to give you 3,730. Okay. Then after that, you take the 230 volts times the 90% times the 80%, and that's going to give you 16.56. You divide that into it, and that gives you 22.5. Okay.
Right.
So it's just like we did last week. Nothing has changed here. And if you look here again, I'm coming in, I'm going to find here what my amperage value is, and I have some known values here. I know the KW is 83.2 KW. I got 240 volts, and I got an 80% power factor. Take the 83.2 is time 1,000. We want to put it in VA form, so that's going to give me 83,200 VA. And like I said a while ago, everything else I multiply together, then divide into it, right? Now, the only difference in this one, it's a 3-phase, so I have to take it at 1.732, then the 80% power factor. That's going to give you 332.5, divide that into it, and that's going to give you 250 amps, okay? Right. But the thing I want to point out here is I took KW. Let me go back one here. I just want to make sure everybody pays attention. and I took the horsepower rating here. I got that value, and then everything else was added together and divided into it. Okay?
And just so everyone knows, that 1.732 is the square root of
3.
pi.
Yeah.
Or square root of 3.
Yeah. Now, looky here. We're going to find the amps again here. And I know what my kVA is. It's 104 kVA. And then I've got 240 volts, and it's 3-phase. There's no power factor or efficiency here. So all I'm going to do is the same thing. I'm going to take the 104 kVA, take it at 1,000, because I want to put it in VA form. That's 104,000. Then I'm going to take the 240 volts times 1.732, and that it'll say like 415.68. Anything over 0.5, just round up. And that's going to give you 416 volts. Divide that into it, and look at there. We got 250 amps, just like we've been doing. Okay?
Right.
Now.
Hey, I got a complaint on that last illustration.
What's that?
You didn't put an outlet in there.
Oh, well, sometimes you got to leave some things out, man.
That's funny.
Okay? So just remember, when I'm doing amperage here, I've got kVA, I've got kW, and I've got horsepower. Everything's added together there, and then the rest of it is multiplied, then divided into it. Now what I'm going to do here is I'm going to determine what the kW is. Okay? So all you're going to do here is you'll look at the known values. You know what your amperage is. It's 250 amps, just like we've been doing. 240 volts. It's a 3-phase 1.732, and I have an 80% power factor. All you're going to do is just multiply all that together, and that's going to give you 83.2 or 83.2 kilovolt amps. Pretty simple. Okay?
Yeah, and you guys can go back to last week, and this will make a lot more sense because James describes how you get all these different values. So, like if you have one known, or you have two known, and you have one unknown, then this is how you find the unknown. So they all kind of work in relative triangle to the pie chart.
Sure. And the same thing happens here. I've got an amperage 250 amps, 240 volts, and it's a 3-phase system, 1.732. Add all of it together. I want to put it in a VA form, so I divide it by what? 1,000.
Yep.
And that's something I explained this last week. Anytime you need to get it in VA form, you're always doing what? 1,000. Yep. Either I'm multiplying or I'm dividing, whichever way I need to do it to get it in VA form. So all I'm doing is taking the 250, 240, and the 3-phase at 1.732, multiply it all together, divide by 1,000, and that gets me in my VA form.
Yep.
So that's what I try to tell everybody. This is all very simple to follow along right here. The same thing. 22.5 amps, 240 volts, efficiency 80%, 90% power factor. I want to get it back to being what? A 5-horsepower motor where I started. So all I'm going to do is what? Multiply everything together. And let's see what that is right there. I forget. I don't remember that exact thing off the top of my head. 240, 80% times 90%, 38888. I was thinking it's 3868 or something like that. Okay, so you take the 3888 and then you divide it by what? How many watts are per horsepower? 746.
746. Yeah.
So you take the 746, and that's going to give you 5.2. I'm not over 0.5, so I round down, which gives me what horsepower motor? 5 horsepower. Now see?
Oh, okay.
That's pretty simple. But remember, when you're dealing with motors, you've got to have that 746 in there. Okay? So if I went back to the very start, I multiplied the 5 horsepower by 746 because I need to get it in amperage. This one
awesome.
here.
Thanks for joining us. Appreciate it. Sorry to interrupt. Go ahead.
What you're doing right here is you're taking all of this, and you're multiplying it together, and now you got to divide into it to get back to the 5 horsepower. You're doing the same thing, you're just doing it in reverse, right?
Yep.
That's the only difference, because I have the amperage this time. Okay.
All right.
Now, Ohm's law. This is simple. You remember the other day, you can look at the wheel that's up there. I said, if I put my thumb on E across from each other as I time R, which means I'm going to multiply the amperage and resistance, right? Okay.
Yep.
So I got 0.645 amps and I got 186 ohms. So I multiply that together, and it gives me 120 volts. Pretty simple. Yep. Okay. If I go to the next one, here's my current. Well, if I put my thumb on it, E's above R, E is the voltage, so that means the resistance is going to be divided into the voltage. So I have 120 volts, 186 ohms, divide that 186 into the 120, look what you get, 0.645, just like we did for the last one. Now look at here, resistance. E is over I, so I'm going to take the 0.645 amps, divide it into the 120 volts, and look there, it gives you 186 ohms.
Nice.
Now, as far as I'm concerned, that's about as easy as it gets. If you can just remember, put your thumb here, remember this wheel, you have it. Now, if I go to a pi formula, the same thing here. If I want to determine the power, I put my thumb on P, that's why we call it pi. So you don't, in other words, we're not doing any resistance here. So I across from E means it's going to be multiplied. Well, in this problem, I got 31.25 amps and 240 volts. I'm just going to multiply that together, and it's going to give me 7,500 watts. Okay?
Nice.
Then if I want to know what the current is with the power and amperage, well, P's over E, so that means I'm going to take the 240 volts, divided in the 7,500 watts I just proved, and what amperage did I use over there? 31.25 amps.
Right.
Okay. And then if I want to know the voltage, P is over I, so I'm going to divide the I into the P. That'd be 31.25 amps divided into the 7,500 watts, and voila, you got 240 volts. Now, up to this point, I'd have to say that's pretty easy.
Yeah, and one thing I was gonna say to Oscar is the way James took you through that was basically all the way around the triangle. So you went from one side of the triangle all the way to the other side of the triangle. So basically, you did every single part of that formula there.
Sure. And it's not that hard. Now, this next one's where you got to start looking, because you got to remember the, okay? And like I said, some of the basic is in there. But if you're finding power, this is what you need to remember. The amperage and voltage are going to square, okay? The only difference between the two is if you have, it's just like if I'm looking at IR and I had that wheel there. Basically, E is over what? R, okay? Yeah. So you're dividing the resistance in, but I and R are across from each other, so you're multiplying it, okay?
Right.
And that's why you look at that wheel. Then, of course, you have your pi formula. I is across from me, so you're going to multiply it, okay? So I got an amperage of 0.645 amps. I'm going to take it at 120 volts. I multiply that together, and it gives me 77. Okay? Now, all right, watch this. When I come here to that one, and I'm going to use the resistance and the voltage, the only difference here is you want to square the voltage. On the next one, we're going to do the amperage, and you're going to square the amperage, okay? And the only two difference, just remember, I across from R, you multiply, voltage is above resistance, so you're going to divide into it, all right? So I've got 120 volts, and I've got 186 ohms. I'm going to square that 120 volts, which you'll see in step 3 is 14,400 volts. Then I'll divide the 186 into it, and voila, once again, 77.4 watts. All right. Now, Here comes the next one. I've got the amperage, it's 0.645. I've got the resistance, 186. Then I take and square that amperage is going to give me 0.416. I'll multiply that time 186 because they're across from each other. And there you go. You got 77.4 watts. Now, that's the way I teach the wheel for the power is voltage is above resistance and I and R across from each other. And if I've got I and R, I've got to square the amperage and I've got to square the voltage. That's how you want to remember that wheel. Okay, for that portion. All right. Now, the next one you're going to look at is current. Okay. Now, let's look and see if I'm still holding true. Is P over E? Yes. So I would divide E into P. Is P over R? Yes. So I'm going to divide R into the P. But the difference is here, you're going to square the whole thing with the power to get the amperage. So just remember, everything else, we've already done the calculation part. But in this portion, when you're at current, just remember R is divided into P and you square the whole thing. Okay?
Yeah, and just to give people some heads up, what you should be able to do, they do give you permission to have scratch paper when you're in your exam. So you are permitted to draw this out, to basically draw this wheel out on a piece of scratch paper, and it's not considered cheating on the exam. You are permitted to memorize this wheel and draw it all out to help you out in the exam.
Right. I mean, it does change once you get in. What I like to point out is, like, when I get to the voltage part, the P and R is going to be multiplied, then squared. But see, you're doing current, it's going to be a lower value. That's why you got in to doing it's going to be a higher value. That's why it's multiplied. Okay?
Right.
These are just little teaching techniques. You know, I've sat in a lot of classes where I've seen people teach basic Ohm's law theory, and I've never heard them say this stuff. And they just say, you do this, and here's the values. I always try to look at everything. Is there an easier way for you to remember it? And this is the way, believe it or not, is the way my dad taught me. Okay? He said, this is the way I remembered it when he was going through apprenticeship and school. And trust me, it's easier. It really is.
Yeah.
So here we know the voltage is above resistance. So I've got to divide the 186 into the 120 volts. That's going to give me 0.645 amps. Okay. Just like I started here. If I come back here and I look at my amperage, what was that? 0.645 amps. Okay. So everything's holding true so far. All right.
Yep.
Now you've got the power. You know, we looked at the power wheel. P is above E, so I'm going to divide the 120 volts into the 77.4 amps is 5 amps. So we're still keeping correct. Now you look at the next one, and this is where you have power and resistance. I need to divide the resistance into the power. So I'm going to take the 186 divided in the 77.4. Let me see what that value would be because I didn't write it down. I just know how to do the calculation, so I know how to do them. Let's see, 186 and let's see, 77.4 divided by 186. That's going to give me that. Then I'm going to square root it here. That's going to give me 0.416, and then I'm going to divide. Well, that's interesting because the 0.416 is what I got a while ago when I squared it. And once I squared it, gives me 0.645 amps. That's cool.
Right.
Okay?
Yeah.
So everything's still holding true. Now, same calculations here. The only difference add here is I'm finding voltage and the P time R. Remember, if I'm doing amperage, I divide, but here I'm going to multiply because I'm going to have a higher value. So I'm going up to 120 volts and I'll square root that. Okay? So in this first one, I have the amperage and resistance. They're across from each other. So I'll take the 0.65 times 186 ohms, that's going to give me 120 volts. Then I come over here, P is above I in the pi formula we showed earlier with the wheel, and that means that you'll divide the amperage, which is 0.645, into the wattage, which is 77.4, and that's going to give you 120 volts. Okay?
Right. And
then here, same thing. You're going to multiply this instead of dividing like we did for the current. So I'll take 77.4 watts times 186 ohms, square root that, and that's going to give you 120 volts.
Right.
And I'll guarantee if you take and divide it, you're going to be so low, you're going to know that voltage isn't correct anyway. So
True.
that's one way you'll know damn good and well you messed up.
Well, that's a good, that's one of my pieces of advice for people. A lot of the things what I did on my test was I would take some of the answers and I would plug them in and do the calculation. If it came out to one of those other numbers, then you knew you had the right answer. Right. So you can reverse it too.
Right. Now, this is the one point here that it doesn't hold true what I've been saying. And this is where, because the power is always above the voltage, but in this case, when you're doing the resistance, this will be the one little thing you'll have to remember is the voltage will be squared, then you'll divide the power into it. Okay? Everything else holds the same. You're still going to do the amperage and the voltage that's squared like you did when we were finding the power. The only difference here is that voltage is going to be squared into, it's going to be divided by the power, okay? Right. But everything else holds true. P is above I, you're going to square the I and then divide it into P, okay? So this is the only one spot that everything I've been telling you up to this point, it changes a little bit right here, okay?
Okay.
Now, this one I have the voltage and the amperage. I'm going to take the 120 volts and I'm going to divide the 0.645 into that 120, and that's going to give you 186 ohms. Then I'm going to do the amperage and power. I've given you those loads. I had 0.645. When I square root that, that's going to give me 0.416. And then I had 77.4 watts. I divide that 0.416 into it, and it gives me 186 ohms. Then you'll just take the 120 volts here. This is the one you got to remember. Square that. That's going to give you 14,400. Then you divide that 77.4 into it, and it'll give you 186 ohms. Okay?
Right.
And up to this point, that is the best way I can explain how to remember that wheel. Okay? Everything still works the same except for where you got to do your squared. The only time it changes is when I'm at resistance. And if you got the voltage and power, just remember the voltage is going to go above it. You're going to square it, then divide the wattage into it. That's the only place that it changes a little bit from the way that we calculated it earlier. Okay?
Nice.
All right. And that brings us to doing some example problems for the voltage drop calculations. Now, what we're going to do is I'm going to show you a branch circuit here for single phase, and then I'm going to do one for three phase, and then I'm going to show you how to do it I'm going to show you the first two calculations. I'm going to show you how to do it applying the formula where you have 2, which is a constant, time your length, which is L, time I, which is your amperage, time R, which is your resistance, and the resistance of the conductor is going to come from Chapter 9, Table 8. And then once you have all that added together, we need to get it back into VA form. So what do we divide by? 1,000. Yep. Okay? So what it says here, and then after we do those two problems, then I'm going to show you how to do it do a voltage drop calculation, doing it all in circular mill based on the circular mill of the conductor. Okay?
Nice.
And I hadn't seen another publication do that. I'm sure there's one out there. But we felt these were the two everybody uses, so we thought, we need to show this so everybody knows the two different types of calculations. Now, This first one, I'm going to tell you right off the bat, the conductor size is going to be too small. So we're going to have to increase the conductor size. Okay. So it asks me here, what is the voltage drop for branch circuit conductors that are run 250 foot and are number 2, AWG, THW, and copper conductors? You have a 120 amp load. Both ends are connected with 75-degree C terminals, supplied by a 240 volt single phase circuit that has a voltage drop of 3% applied. Now, one of the things that I will point out here is you're going to be doing these voltage drop calculations, and you're going to look at 210.19A, informational note number 3, and then when you get to a feeder, it's 215.2A1, informational note number 2. Now, one of the things I want to point out, if my feeder and branch circuit have to have voltage drop for both of them. Usually what most people do, they do the branch circuit at 3%, and then you'll take and do 2% for the feeder, because you cannot exceed 5% overall. Okay?
Okay.
And
Gotcha.
and you know, I could throw all these sections up here, but what I want people to do, that's why we have homework for this, is I actually want you to go back, look at your code. I'm going to tell you what it says here, but go back and look at your code book, and you'll see where this information's coming from and what I'm telling you, how they're applying that and what it means. Okay?
Well, and just for the people like Oscar out there, this branch circuit of 3%, that is not enforceable. So, like, an inspector can't come out and enforce that on the project, but they want you to know it when you're taking the exam.
Oh, sure they do. And matter of fact, we'll do another one here probably about summer, but I'll go in and I'll pull out and explain. Usually when you want to start looking at doing voltage drop calculations, if you're on the job, is once you get over 100 foot.
Yep,
okay?
I agree.
And I went through that and explained that last time. We showed a number 14 that was good up to like 50 foot when it was a solid conductor from the American Standards handbook. And that was a long time ago. They did those calculations. And then it went up from there. Well, once you started using stranded, they basically doubled the length. And because you had the air in the conductors and everything. And then that's when they started saying, typically you want to start looking at doing voltage drop calculations at 100 foot or more. Okay.
Yeah, and that's one of our thumb rules that we popped in. So
Yeah.
I'm proud of.
It's just one of those things, I try to impart on the younger generation what was imparted to me by the older generation, and,
Sure.
I was fortunate, I was there with Dad and God, I just got Mark Odie and Calogero. I'm trying to remember the guy from Louisiana, Finch or something like that. I can't remember his last name. But I got to go listen to these guys all the time because I was hanging around with Dad. And that's how come I have a great knowledge on this stuff, is because it was, I like to say, it was bestowed upon me,
Right.
And if you're willing to, not sleep and pay attention, you're going to learn something,
Yeah, true.
So anyway, I'm just sort of giving everybody what I learned. Now, if you go to 210.19A, informational note number 3, we're going to say we're going to do the branch circuit at 3%. That's what I said we were going to do it at in the example problem. And then you go down to step 2, and I said we're going to use this basic formula for voltage drop. 2 times L times I times R divided by 1,000. 2 is a constant. We had 250 foot run. We had 120 amp load. And then if you go over and you look at chapter 9, table 8, everybody can go look at this. I'm just going to tell you, you're going to go over and uncoded while you're going to come down and find that 0.194 for the resistance of that conductor. Okay?
Right.
Now look at this. I said, anything you're dividing by 1,000, like we did earlier for the AC DC, I said, you got to get it over in VA form. What are we going to take it at? 1,000. You're going to divide by 1,000. So you add all that up together, gives you 11,640. divide it by 1,000. That's going to give you 11.664 volts. Now, let's see if it's above what is the allowable voltage drop. Well, I got a 240 volt circuit. Take it at 3%. What does that give you? 7.2 volts. Well, the 11.64 is larger than the 7.2 volts. So we automatically know that the conductor is too small for the voltage drop that's going to be there. That's how we cross-check everything. All right?
Right.
So then I'm going to go in and look at doing this again. Now, if I take the voltage drop, divide it by the voltage, let's just look and see what we get. You take 11.64 volts, divide it by 240 volts, that gives me 4.85%. That's not 3% or less, is it? So the 11.64 volts is greater than the 7.2. All I did there, we did an extra step to show you the percentage based on whether if we did it by volts or percentage, you can see we still got a problem here. So now what we need to do is use a larger conductor. I've already pulled the conductor out for this problem, but when y'all do it in the other, you're going to have to figure this out. You may have to do an extra calculation because you may go one size that's not enough. You may have to go two sizes, okay? So you're going to have to do the calculations to figure this out. So what we want to do here is we want to reduce that 4.85% to what? 3% or less. Yep. So in this case, we're going to use a 2-aught conductor, okay? I'm going to do the same problem. I'm going to apply 3% in step 1. Then I'm going to go to the next part. Same calculation. The only difference I'm changing in this calculation is what is the resistance of the wire. And in this case, the 2-aught is 0.0967 ohms. It'll be over in the uncoated wire. Y'all go look it up. Then that's going to give me 5,802 divided by 1,000. That gives me 5.802. Divide 240 volts into that in step 3 and look at my percentage now. Now I'm at 2.4175, which is below 3%, and that will take care of my voltage drop.
Yeah, and one thing I want to do a shout out to everyone out there like Oscar. We're not trying to confuse you on this. What we're trying to get you to understand is you could do the calculation, and if it doesn't come out right, you could just change one thing of that calculation and you can make it right.
That's right.
That's where it's not like we're trying to say that you're going to have this calculation on your exam. It's just when you see those kind of calculations, all you need to do is just increase that conductor and you're going to lower that voltage drop.
Sure, and as you practice it more, you're going to realize how easy it really is. It's not that hard once you understand the principles. And that's something I've always taught. Understand the principles. If you get the principles down, you're going to understand everything else. Okay?
Yeah.
Now, this will be your exercise problem for next week, and there's a lot of blanks to fill out here. You'll see on the left-hand side of the illustration there, we're telling you have an 80 amp load. We got 200 foot of conductor. You got number 3 voltage drop. It's uncoated wire. We're telling you we want to do a 3% voltage drop, and it's a 240 volt single phase system. Okay? All the information's there. We even take up at the top in the formula requirements to show you the formula that you're using. Then in step 2, you'll see it again. Okay? And then you also get a cool looking illustration right there. I mean, these are the things that you're seeing in the publications that were coming out in the online courses. This is the type of updates that are coming. Okay,
dude. My guess is Senior bent that 90 with his hickey bender.
He did. he hicked away at it. All right.
I'm probably not invited to the barbecue anymore.
That's okay.
Yeah.
If he won't let that, we'll just go have a beer.
There you go. I'm down.
All right. Now, this is a 3-phase. Okay? We're going to do the voltage drop for the branch circuit conductors. You got 250 foot. I'm supplying it 1-aught THW and copper conductors. I have a 120 amp load. It's a 240 volt three-phase circuit, and then I'm going to apply a 3% voltage drop. Just like we said, 210.19A informational note, go over and look at that. Branch circuit, I can take it, what, 3%, okay?
Okay.
Then I come down, I did not change the formula. There's only one thing that's going to change, and you need to remember this. If you have three-phase, once I take and I determine what that volt is, I have to take it at 0.866, okay? And all that is, and I put it in there so you can see it, you take the three-phase, divide it by 2. That's what gives you the 0.866 for the portion of the three-phase calculation. So I look at this, 2 times L times R times I, or I times R, divided by 1,000. 2 is my constant, 250 foot's my length, 120 amps. Then my 1-aught TH copper conductor, it's uncoated. We tell you up there in the thing, use uncoated wire, and it's going to give you 0.122 ohms. Multiply all that together, divide it by 1,000, that gives you 7,320. We want to get it in volts, so I'm going to divide it by 1,000. That's going to give me 7.32. Then I'm going to take that 7.32 times 0.866, and that's going to give me 6.34. I can already tell you this is going to work by one reason. Because if I take 240 volts at 3%, it gives me 7.2 volts. That's going to be below the 7.2 volts. Okay, yeah. So I go into step 3, looky there. 240 volts times 3%, 7.2. That is lower than that, but if I want to clarify it more, take the 6.34 volts I just did, divide it by 240 volts, and it gives me 2.64, which is less than 3%.
There you go.
Now, you look at that, everything stayed the same. The only difference I did was the 0.866 because it was three-phase. Okay?
Oh, yeah.
Now, this is another type that you're going to look here. You'll see right up here, we're doing this calculation. Same illustration, looks just like the other one. Nothing's really changed except for what? The voltage, and it's three-phase, right? You still got your 200 foot of conductor, number 3 conductors, 3% voltage drop, and use uncoated wire, and the load is 80 amps. Okay? The only difference is I need to add what? The 0.866 for the three-phase.
True.
Okay? Now, this is the last one for this night, and next week we'll come over these, and because, you know, they're bigger problems, is we're going to do a voltage drop calculation here, but we're going to do it based on the circular mills. Okay, so we're going to change the calculation just a little bit. All right?
Right.
So we're going to ask you, what's the voltage drop rating for feeder conductors that are run 150 foot? You've got 95 amps of calculated load, and I have a 240, 120 volt three-phase system, and I'm going to do a 3% voltage drop here. All right? Okay. Now, if you go over and look at 215.2A1 informational note number 2, just like I looked at 210.19A informational note number 3, they give you the option here. I could do, if I did 3% here and I need to do voltage drop for my branch circuit, then the branch circuit can only be 2%. Okay?
Right.
And you'll go read all that. It'll be there. So then you take the 240 volts times 3%. That's going to give me 7.2 volts. Now, that didn't change, did it? We still kept that same type of voltage rating there at 240 volts.
Right.
Now, when I come down and I look at this right here, my circular mill calculation, I'm going to do 2 times L times I times K. Okay? Now, 2 is a constant, and K is going to be the constant that is used here of 12 for the copper conductor. Okay?
Right.
If you're using aluminum, it's different, but we're doing copper here, so we're going to keep it the same.
Yeah, 12 is copper, 19 is aluminum, I think.
Right. Now, if you look at the 7.2, that's why we got it up there, because we're going to divide that volts into it, okay? And that's going to give me what the circular mill is. So I'm going to take all that. 2 is the constant, 150 foot in length, 95 amps, and K, which is going to be the constant for copper conductor. multiply it all together, divide by 7.2, and that's going to give you 47,500 circular mil. Now, what you're going to have to do is go to Chapter 9, Table 8, and you're going to go over to the circular mil column, and you're just going to come down and you're going to look for the next conductor that is above 47,500 circular mil, and that's going to require you to have a number 3 copper conductor. Okay?
Yeah, so the way you do that too for the guys out there is you're gonna pick whichever one is larger. So like I would just be willing to guess that the number 3 is larger than 47,000, so then that would be adequate. Mm-hmm. If it's below, if like say the number 2 is 46,000 something, even though it's close enough, it's still not adequate. You have to go up to the next standard size.
Sure. And circular mils gets used in a few different calculations. You know, like I could do one where, say, I'm looking at the size equipment grounding conductor if it needs to be larger due to voltage drop. Okay, I'll give you an example. Say I got a panel here and I go over here and I hit another panel. I'm running the feeder over there and say I'm going over, it's 175 amp is what I'm going to put there. So if I go over and look at that and I go to table 310.16, that's going to be a 2-off conductor, all right, because it's good for 175 amps in the 75 degree C column. Now, right. if I have to increase the size over there to a 3-off conductor due to voltage drop, now if I go look at 250.122B, it's going to get into the circular mil because you would have to increase the size of the conductor. So what would happen here is I would take the 3-off conductor, get the circular mil in Chapter 9, Table 8, and then get the circular mil for the 2-off conductor. And then for 175 amp going over, if you go look at Table 251.22, it's going to tell you need a number 6 equipment ground going over to that. So I would take the 2-aught circular mil divided into the 3-aught circular mil, and it's going to come out to like 1.256873 or some crap like that. So you're going to get that multiplier, and then you're going to take that multiplier and put it on the circular mil of the number 6, and then it's going to give you a value of like 43,000 something, and then it's going to tell you the next size above that circular mil. You would even had to increase the equipment grounding conductor to a number 4. Okay, so those are things that you know we'll get in more depth when we get over
and there's other times where sometimes you have to take a 600 amp and turn it up to a 620, so you have to do that too. So
and then as I said, all your information's in the illustration there. Your voltage is 240, 120 volt, 3-phase. You got 82.5 amps of load. You got 125 foot run, and we're telling you do it at 3%. And that should take and get you prepared for next week when we come back on how to do the voltage drop calculations.
Woo! Nice. Love it.
Mad for an old fart.
Awesome. Yeah. Like I said, if you guys have any questions, we're compiling a list of stupid questions. I already have my stupid questions out there. We'll answer them when James has some time in his topic. But
the topics take so long to do, you know, because when you're dealing with calculations, it takes time to go through them all and explain all the intricacies and parts of it you have to think about.
We'll make a segment for questions. Like if you guys have questions, we'll save them up. And I know James already saved mine. You saved mine, right?
Yeah. Matter of fact, if y'all enjoy what we're doing here, make sure y'all tell the other people out on the jobs or any other, have them subscribe to the channel, because we're trying to build the channel up, and we've got a lot of other videos on there besides this, and I'm going to be adding them through the year, and we're going to have by the end of the year 500-600 videos on there. So it's going to be fantastic. And our write-ups and stuff like I'm teaching here, that's pretty much it. You know, I have a video with voiceover, and I type it all in, and it explains everything just like I'm doing here. So hopefully everybody likes what we're doing. If you do, give us a like.
Yeah,
and all that.
awesome, Oscar. Yeah, that's
Appreciate it,
good, man. Yeah, we hope you understand everything, and we'll keep trying to refine on it. But until then, we're gonna go to the tool review.
Here we go.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, so this week we're gonna be talking about a new tool, and I saw this come out. I think it's on clearance right now, but I think they did some like real super hardcore improvements, and I think this is probably one of the better stackable tool bins that they have out there. The DeWalt 2.0 stacker box, and they're trying to rival with the Milwaukee Packout, but there's a lot of really rugged features with this one. I think that top part actually has like an organizer thing on it, and then the other parts are like more for like your tools to fit in. But I really like this one, and I think it was actually cheaper than the Milwaukee Packout. Don't quote me on that, because they all pretty much pay for. That's all you're paying for is pretty much the name on there. But at the same time, I really enjoyed this one. A lot of guys brought this in, locked it up on the job site, never had any issues with people messing with their tools. So altogether, for price, durability, I heard the wheels might have had a little bit of issue. One of the guys said that he had issue with the wheels, and he took it back and they replaced it, and he hasn't had any problems since. So as far as I know, this is a pretty good product, pretty good new product, and so like I say, will recommend to anybody that's looking for something durable, pack out style. So I know this week with the code question of the week, it's kind of a little bit of a repeat. I did it just to see if I maybe catch you, off your game a little bit. But at the same time, I was kind of trying to, give people a little bit something where I just did a little bit of a repeat, see if they remembered from a little while ago. It's been a while. So let's see if you remember.
Let's see what you got. Let's see. I think that's report. Oh, that's for American Mixer 2020. Yeah, I think for a 120 it's like 10, but for 208 I think it's 6 feet. I think it's C. I think it's like 440,
yes, sir.
62 or something.
You nailed it, and the whole rest of the groups nailed it. I got a couple people on that one, but I really like getting people on these because it kind of keeps you guys sharp, keeps you on your toes. So next week's going to be a completely different one that I'm going to try to get James on. But, yeah.
I've been doing pretty good on them, baby.
So this week I wanted to make an easy Willie quiz. I was testing the people at the gas station, and they got it right. So like, there's been a lot of people got these right, and I was kind of like, oh man, I must have made it too easy for James. But we'll have to see. I try to make these that you're probably gonna know. Like, so just so everyone knows, James went 3 for 3 last week, so he got all 3 right. So I had to like
That's right.
I kind of had to up my game. I had to get him like even easier, so that I can maybe get him second guess himself a little bit, and maybe get a few victories on the old Willie quiz.
All right, let's roll. All right, this is gonna be fun.
entering the zone of the Willie Quiz. Enter at your own risk.
All right, so I put you guys together a really awesome quiz this week. I think you'll really like it. I made it easy for James, so if you guys want to jump in and try to answer these, I think you're going to be really liking these. So, the hottest temperature ever recorded on Earth was blank degrees Fahrenheit. Was it A, 129.9 degrees? Was it B, 133.3 degrees? Was it C, 134.1 degrees? Was it D, 135.7 degrees? Or was it E, 135.9 degrees? So, good luck, everyone. So the good news is Daniel J shows up out of the blue and he goes C. Oscar's going A. So we have a couple good answers already. So we have some answers in the chat. And James doesn't like to copy Daniel. All right, so Daniel's going C. Maybe you should copy Daniel.
I know it's in the 130s. And if I wasn't mistaken, I thought I read sometime. I remember hearing something about this, but I thought it was like 137 was up there.
So
Oscar's
Oscar's not even going in the 130s, but
I think it was like 136, 137. I read that somewhere one time. That I think I saw it on the news channel one day because it was real hot in Texas that day. He goes, well, at least it's not the hottest one. The hottest one recorded like 137 or something like that. I know it's 130s. I remember that. But I think it was higher than 135. But I'm going to go with E.
All right. So James locks in at E. Man, James, I'll have to tell you right now that Daniel takes the win on this one. The answer is C, 134.1 recorded at Death Valley, and I think it was in the time frame you're thinking about. But yeah, Daniel takes the win on this question. So good call on Daniel there.
Well, I knew it was in the 130s. I just couldn't remember what he said because it's like 15 years ago.
Yeah, it was a while ago,
Daniel.
But yeah, good one. All right, dude, I tried to give you the option to copy Daniel. You didn't want to do it, but it's all right. It's all right. All right. Question number 2. Lightning strikes the Earth about blank million strikes in a 24-hour period. So this is regardless where you are in the world. This is how many times. How many million strikes in a 24-hour period around the globe? Is it A, 5.7 million, B, 6.1 million, C, 7.1 million, D, 8.6 million, or E, 10.1 million? Good luck, everyone. All right, so no answers in the chat. So if you guys want to put answers in the chat, James would like to copy him. All right, so Oscar right away is going 10.1. I think he's going E. So
can tell you right
10.1.
I have
Ooh,
no
Daniel.
clue.
Ooh, Daniel's going 8.6. Ooh, man, I don't know. I mean, those are pretty. I know James likes to take the under, but I mean, I don't know. I mean, I think you just took the over. You took the over any of the answers on the last one, so we'll see. I mean, you know,
I'm just going to guess. I'll go with B. I have no freaking clue.
B. All right, James locks in at B 6.1. We have Oscar over there. Oh, he's copying, going E. All right, okay. So we got some copying going on. Oh man, James, I really think that 2024 really helps you out a lot, but you're wrong. Daniel J gets it at 8.6. He's got 2 correct answers. Daniel J is already 2-0 against your 0-2. Oh man, you should have been copying Daniel. Why didn't?
I told you I had no freaking clue. I just guessed at it.
Dude.
When I go 3 for 3, people like, he's got the answers, and I go for 0 for 3. Like I never look at any of these. I just guess at them.
Yeah. No, it's all good. Like I say, this last one, I saved this just for everyone. This is a great one. I learned this.
I know this one.
Okay, James knows this one. All right. Every snowflake has blank points or sides due to the way the snowflakes form. Is it A, 4? Is it B, 6? Is it C, 9? Is it D, 12? Or is it E, every snowflake has random points and sides? Good luck, everyone. All right, so Daniel comes out of the gate right away with random. Every snowflake has random points inside.
Wrong.
Great answer. Yeah, dude, everyone's answering E. Everyone's answering E.
It's
dude.
B. It's B.
All right, so, dude, you have like so many good answers in here. James is like claiming victory right now with B.
It's
6.
I know this one. It's 6. It better be. I remember talking about this one time.
Oh, man.
Go ahead and say I'm right.
Oh, man.
You can say it.
James is correct. He actually gets one. Oh, man, he got it. Dude, even the dude at the gas station got that one. When he said it, I was like, oh, man. I was like, I thought I was going to get him on that one. Dude, the gas station.
I think, if I'm not mistaken, we were playing Trivial Pursuit or something, and that came up. It was something we were playing some game, and that's how I knew that. Because everybody said, there's no, it's whatever, and I was like, I actually agreed with them. I didn't know they had 6 points. I was like, I'll never forget that.
I told you I made it easy. See, like I told you it was easy. I knew you were gonna. I had a feeling you were gonna know that one, so I wanted to put it at the end, so I can at least get you on some other ones. But thanks all the chat.
Go ahead and say it. I know it's right.
Appreciate everyone in the chat for participating. Dude, Daniel still got you. He's got 3 wins against you, dude.
He does.
Dude, Daniel's doing good. All right, so James, you're gonna have to make the podcast about how Daniel has all the answers.
I am. I'm doing a special podcast. I'm gonna say, Bill and Daniel, they're conspiring against me.
they're a cancer to the trivia industry.
That's right.
That's funny.
They think they're freaking on Jeopardy. And Bill's whatever the hell the guy's name is.
I'm the ringmaster. I'm the ringmaster against James. I'm the
Oh shit, I love it.
Oh well, I already influenced your thinking. I latched on, or you latched on. I latched on to you, and then influenced your thinking. I think is what they said.
Oh yeah. Whew. Yeah. Whatever.
All right, we got an awesome wall of shame this week. Let's roll
All right,
it.
let's roll it.
Shame. 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 Shame.
Yeah, this one, when I saw it, it just cracked me up, and they're like, it actually got posted in electrical code discussion for awesome electricians again, but it's like, can you believe that they put the wrong style outlet in there?
I can't
The
believe
wrong-
Evan did that.
Yeah, a white faceplate with a beige outlet, but yeah, and yeah, Devin Hollingsworth was credited for this picture in the wall of shame, so appreciate you, Devin. We're gonna be picking random stuff and just posting it on our podcast, and really appreciate it.
That's funny.
Awesome. We don't care where you stole it from, but that's hilarious.
That is that's choice, man. I love that one.
Yeah.
I had to say this. That's one the main reasons I love doing the podcast is because we cover all these ideas, but we're having fun doing it, and it's stuff like that makes it fun. Otherwise, you probably wouldn't even saw it or something, and we're actually finding these things. We're like, and this is that's what makes it awesome. Freaking love it.
Oh, dude, just wait till you guys see my wall of shame pick for next week. I'm almost thinking it should be cover picture. Like I don't know. I'm gonna have to talk with the guys. We might have a new cover picture this week. It might take the cake. We might be able to throw it up there. But if it does cover picture, you guys are gonna have a treat for next week. You're gonna have a wall of shame cover picture that is just it'll make your eye twitch. It's that bad.
Oh, I do got a question for everybody that's watching. Put comments and stuff in there if you like the way we're setting the Journeyman up, where I cover everything in example problems, and y'all have the exercise problems from homework. That if y'all are liking the way we're doing that, because I wanted to make it. It's one thing I can sit here and tell you all day long, but I also thought it was probably good if you were able to go back, fill in the blanks, and look at the code book and figure this stuff out. And then we come back the next week, go through it. If y'all still are liking that format, because I can just teach it and be done earlier, but if y'all are liking it that way, let us know, because that is why we're doing it that way. So just
you got a good one. You got a good one from Oscar. Oscar's loving it.
thank you.
That means a lot, because Oscar, I think he needs like one time to pass his test. That's it. He wants to, I don't know if he wants to take it any more times. He's taken it a few times, and he wants to pass it this time. So
Well, I'll tell you, you'll know the
appreciate that
calculations
comment.
by the time we're through, because, even if you're taking a master's, by the time I go through everything in detail, you can pass the master's. So,
Yeah.
and usually most of the tests now, they stop when it comes to doing residential and commercial calculations, the full calculations, that'll be the last part. So if you want to watch it, you can, but the people who are studying for the masters, that's going to be at the end. Everything else, I'll have all kinds of stuff in between there that deals with masters and Journeyman. But that last part is mainly for the masters. They're going to take it. But as a Journeyman, I think you should know it anyway.
True, and you guys can save up your stupid questions. Like I asked a couple stupid questions. There were some other people that asked stupid questions, so we'll save them up, and we'll do just like a night where we cover stupid questions. And they don't have like I say, I joke around about the stupid question part. No question is stupid. The only stupid question is the one you don't ask.
That's
But the thing is that, a lot of times I'll see guys on the job, and Oscar knows about this. He'll be like, hey, I have a question. And I'll be like, oh, okay. And he goes, no, just answered it. You know what I mean? And so the whole thing is that's not necessarily a stupid question. That's what we're trying to do with this podcast. We're trying to get like your rational thinking to where you can think through these things to where you don't have to ask the question. And it's not necessarily a stupid question, but there could be questions that maybe don't make sense to you. And then we can, go through, hey, maybe they don't make sense to us either. There's a lot of them with like gray areas of the NEC where we'd be like, you know what, if it was in an exam, I'd answer it this way, but if it was, me out in the real world, I wouldn't do that. So there's kind of a gray area in there when it comes to the code language, and you guys have to be clear on that stuff.
Sure. And if y'all know anybody that's going to be prepping for their test or anything, tell them to come on and listen. They can catch up.
Yeah.
If they'll go over to the Stallcup Electrical Education YouTube site, go over there, they can pick up the last 2 episodes and catch up to where we are right now. So,
True.
Because we're just now really getting started. So, the hard stuff's about to start coming. What we're doing right now is pretty basic in my opinion, but once we get through the wiring methods and then we start getting into the conductors and overcurrent devices, that's when we're going to get busy.
Yeah, and if you guys want to do like a quick crash course, like if you already scheduled your test and you want to do a quick crash course, go over to the Nat King Code page. All you have to do is type in Google Me 123 on Facebook, and it'll take you right to my page. And just go through all them questions. Like, we have so many questions in there. I'm not saying we, but they're my questions. I'm going to take blame for them being wrong. But I put the questions in there, and they're actually out of exam books that are recycled exam questions. And so you can go through each one of those questions and just try to see how fast you can find them. And then you go through, try to find out how fast you're going to find them, and then when you go to your test, it's like you almost are still doing the same thing, and even if you don't find the answer, even if you don't find them in the code book, you can look at, I have the answers in the comments, so you can look at the answer, you can find it, then you go, okay, that's where it is, okay, cool. But you have, like, what I try to do is you try to find it within 5 minutes or less. So if you can find it in 5 minutes or less, you're going to pass the test. Because I would say at least a good 80% of the exam is just being able to navigate the code book and find the answer. And so if you can navigate the code book and find that answer in 5 minutes or less, then you're going to pass the test, in my opinion.
All right. You ready to wrap it up? We've gone
wrap it up.
An hour and 45 minutes.
Yeah, I appreciate everyone for joining. We had probably one of our biggest shows ever with all the people that jumped in, so really appreciate it. Make sure that your grandma, your uncle, your cousin, your nephew, everyone subscribe to the channel. It's going to be awesome. We're going to hit 1,000 by summer, and we really appreciate you guys helping us out with the subscribe. Subscribing, liking. We had so many likes tonight. We had some loves in there. That's awesome. We love people when they hit the likes, the loves, everything. Just make sure and smash that thumbs up button, and it's all good in the hood. But yeah. But what I will say after every show is remember, make every day an easy day.
Amen. Everybody have a good weekend, and we'll see y'all next week. And go Cowboys. And get off here before everybody starts screaming at me.